So now we will discuss about the decision table testing. So actually decision table testing is if you are familiar with the term of truth table, in which where we have different test conditions, like if two combinations are true and true, then answer will be true. If or condition is there, if one is true other is false, it could be true. So there are some test conditions given, and then based on that there is a test result given, and you observe this table, and then you have some actions, how in case if this thing is true, if this thing is false, how it will happen. So like actually decision table testing, which is also a type of black box testing, is normally being used when we have very complex logics to understand, when we have some business logics to understand. We make some combinations, a kind of truth table, and then we decide what will be the action. I have prepared an example for you. For sure, after the end of this video series, we will upload some questions, practice questions for different type of test techniques. But only to give you a short idea, actually here is I have taken like an example. For example, we have two conditions. It's like, say it's it's a truth table given, or a decision table given, also known as truth table sometime, about health insurance. Sorry for the bad handwriting, but I think it will work. Okay, so conditions we have: are you insured? The first condition is this one. The second condition is, are you premier member? So two conditions are given, and based on the conditions the result is there. Either you will be 100% covered with your health insurance, or you will be not. And here some combinations are given. For example, in the first case, in normally in ISTQB exam you are provided this table, and based on that you have to answer some question. Let's say I will ask you, if you are already insured, yes, and you are a premier member, like first condition both are true. This could be a question in ISTQB exam. Then tell, will you get 100% coverage, medical insurance coverage, or not? So you will go to the table, you will see yes, as in the question it is written that both the conditions are true. You will go to the result and will say, yes, I will be 100% covered. So your answer will be yes. Maybe in ISTQB exam it is given that you are already insured. The point number one is you are already insured, and then the second condition, you are not a premium member. Then kindly answer, either you will be 100% covered or not. So based on these two conditions you will search that condition, that rule. For example, it is rule 1, it is rule 2. Let's say what name you can give condition 1, condition 2, but better to say it's a rule or a standard. So based on this you see that already insured, yes, premium member, no, then your result will be no 100% coverage, could be below 100%. So it's a kind of decision table. You have some true and false, some yes and no's, and then based on that you you tick the answer, either it is the result, either it is true or false, is possible or not. Sometime, let's say, some conditions are overlapped. For example, if this condition is already insured, yes, premium member, yes, and then you see if they are swapped, premium member, yes, already insured, yes. So then you can test this if within one rule. And for example, if you see that if both of them are no, then answer is no. If one of them is no, the answer is also no. So there could be different combinations. Now we will try to read what is written in the text. Actually, decision tables are a good way to record complex business rule that system must implement. So when you have complex rules, decision table is best. When creating decision table, the tester will identify conditions of an input and the resulting actions output to the system. These form the row of table, usually with the condition at the top and the action at the bottom. Like this we have already seen, our conditions were at the top and decision was at the bottom. Like here you see condition is top, or decision or result is at the bottom. Sorry. Each column corresponds to a decision rule that define a unique combination of condition and which result in the execution of action associated with that. The values of the condition or action are usually shown as a boolean values, true or false, or discrete values, red, green, blue, for example, but can also be numbers or ranges of number. These different type of conditions and action might be found together in the same table. So the common notation they are telling: for condition, yes, the condition is true, it can be shown as true or 1. No mean condition is false, it can be shown as false or 0. means the value of condition does not matter. Maybe sometime it's not applicable. For example, in some time the condition is not applicable, it can also be written. Action could be X, any like the like action should be occur, or blank mean no action should be taken. So it's quite possible, like based on that decision table you have to check the answer. A full decision table has enough columns, test cases to cover every combination. By deleting columns that do not affect the outcome, the number of test cases can be decreased considerably. For example, you have a combination in which you say that if one of them answer is no, the answer will be the action. If one of the condition is no, the condition action will be no. So just figure out those conditions in which you have one of the condition is no, and cut them out. In this, by doing this, you will cut down your decision table, which will be very smaller and efficient. For example, by removing impossible combination of condition. For example, for more information on how to collapse decision table, see there is an advanced tester for agile level, I guess. There you can see, but it is not needed for the foundation level. I think the things we have understand are fine. The common minimum coverage standard of decision table testing is to have at least one test case per decision rule in the table. At least one test case should be written. For example, I would give you an example. For 100% coverage, for every rule, if you see, at least one test case or one result or action is there. It's very important in this case. This typically involves covering all the combination of condition. You have to cover almost all the conditions, but you can also cut down the similar test cases. Coverage is measured as the number of decision rules tested by the at least one test case divided by total number of decision rules, normally expressed as a percentage. Again, like how many rules have you tested by at least one test case, and how many rules were there. For example, here we have 3 rules. Rule number 1, rule number 2, rule number 3, and here we have tested with one test case for each rule. Like if you say rule number 1, one test case, rule number 2, one test case, rule number 3, one test case, and 3 by 3 is our 100% decision table coverage is the answer. The strength of decision table testing is that it helps to identify all important combinations of condition, some of which might otherwise be overlooked. So like when you have very complex combinations, the decision table helps you a lot actually to understand all the conditions. You can understand all the conditions in one look. It also helps in finding any gaps in the requirement. It may be applied to all situations in which the behavior of the software depends on a combination of condition at any test level. Actually, it can be applied at any test level in all the situation in which the behavior of the software depend on a combination of, like for example, for one action you have had different combinations. So you will come to know in this condition. It also comes with experience. You will tell that for this combination, for this particular test object, I should apply the test technique of decision table. Then and the very important thing, as equivalence partitioning as well as boundary value analysis, this technique, I mean decision table testing, can be applied on all test levels. So this for decision table testing. Now we will like study in detail about the state transition testing.